This video is for Math 0242-1342 as we do review number 2. Review number 2 goes right before test number 2, and then everything's due on October 23rd at 11:59 p.m. There are 4 homeworks from 1342, 2 homeworks from 0242, and the review of the test. All that's due October 23rd. In this video, we're going to go over the review. Here's a data set. Find the quartiles. So you can certainly do this manually if you want to, or we could do it in here. Okay, so I'm pressing stat, and then press enter at the bottom. Type all this data in. 3, enter. 9, enter. 6, 13, 4, 9, 7, 14, 4, 10, 7 and 25, 4, 11, 8, 26, 5, 11, 8, 8, 6, and 12. The best place to see all the quartile information is to go to Stat and 1 over to Calculate. Choose 1 var stats. And this is just one data list, so L1. And if you down arrow 1, 2, 3, 4, 5, this is that 5-number summary. So it gives you the minimum value 3, the lower quartile 6, the median's 8, upper quartile 11, and maximum's 26. So I can get the first quartile 6 and the upper quartile, third quartile is 11. 6 and 11. IQR, the calculator does not tell you this, but the IQR is simply the 11 minus the 6, which equals 5. Q3 minus Q1 is IQR, interquartile range. Okay, upper and lower bounds for outliers, you have to take the IQR of 5. Take the IQR of 5. If they ask for the IQR, it's 5, but if you want to know about outliers, then you multiply that value by 1.5, which equals 7.5. Remember that Q1 was 6, Q3 was 11. So if you add this 1.5 amount to the upper quartile, 18.5, anything bigger than 18.5 is an outlier. So you have to be at least this tall to ride this ride like at the carnival. And if you subtract it from the lower, then you get the cutoff on that side, which sometimes is negative like this. So negative 1.5, you have to be smaller than negative 1.5 to be an outlier. And we don't have any negative values in our data set, so that means there's no outliers on the lower side. If there's any numbers bigger than 18.5, then they are outliers, which there's a 26 right there. There's a 25. That's it. There's 2 outliers on the upper side, 25 and 26. Because anything lower than negative 1.5 or higher than 18.5 are outliers. List the outliers. There's 25 and 26. So there's problem 1. Okay, find a z-score. I emailed you the formula sheet that you can use if you print it before you start your test. print page 1 only at this point. You don't need anything else unless you're going to do stuff by hand. But page 1 actually does have the z-score formula. We were supposed to know it in chapter 3, but it's covered again in chapter 6. So it's right here, standard score, depending if you have a sample or a population. So it's the score, whatever you're measuring is called x, minus x bar sample mean divided by s sample standard deviation. Or it's the score you're measuring minus mu, the population mean divided by sigma, the population standard deviation. So we take somebody who got a skill score of 77. You can do this on a simple calculator too. 77, you subtract whatever the mean is, 70.8, and they have to tell you that. Press equals, whoops, it's a little off screen. There. So it was 77 minus 70.8 is 6.2, and then you divide by this standard deviation of 3.5, and it's off at a long decimal. Here it says round to 2 decimal places. Oh, wait a minute, I might have done the wrong one. In a recent year, the mean score of practical skills, and the other one's innovation challenge. So yeah, we need this mean and this standard deviation actually. So it should be 77 minus this 69.2 minus this 5.9. I didn't realize there were 2 things going on at once here. So takes the score of 77 minus this 69.2 average right here, and then divide by this 5.9 standard deviation. The first z-score is 1.32. Then do it for the innovative one, which uses these 2 numbers. So somebody got a 65 on this innovative thing, and the average there was 70.8 divided by the standard deviation of 3.5. So their z-score is negative 1.66. And remember that z-scores are negative half the time, because by rule, the average is the centering point where you get roughly equal amounts of positives and negatives. Which score is higher relative? Well, positives are bigger than negatives no matter what. So the first one, the skills, was higher just because it's positive, and the other one's negative. Okay, then you can work backwards too, and if somebody has a z-score of 40, this you just do a little bit of algebra to figure it out, because the z-score formula is x minus the mean divided by the standard deviation. Normally you know x, the mean, and the standard deviation, but what if you know the z-score, you want to get a positive 0.40 z-score? What x actual score would do that? And if first we do this for the skills is the first set of numbers. So use 69.2 and 5.9 for the mean and standard deviation. 69.2 and 5.9. And then you just do a little bit of algebra here to solve for x. Multiply both sides by 5.9. Because that will cancel this out. 5.9 times 0.40 is a 2.36. And then we can add 69.2 to both sides. $71.56. Somebody had a 71.56 score. Round to 2 decimals. Okay, don't need to round. It was exactly 71.56. And then the same thing for the other one, the innovative. So 0.2 is going to be the z-score. Do this again with 0.2 right here. And the innovative had a different mean and different standard deviation. It was 70.8 and 3.5. So same steps, multiply both sides by 3.5. .5 times 0.2, 0.7. Add this 70.8 to both sides. That's 71.5. So both of these are pretty close. 71.5. The other one was 71.56. Okay, now number 2 is fully correct. Okay, box plots. Now see, if I remember I had the data in this calculator here. Stat, edit. Remember I typed all these numbers in? And I got stat, 1var calc, 1var stats gave me the 5-number summary. Well, another thing you can do is go to second y equals, stat plot, go in there and turn it on if it's off. If you choose graph number 4, go down to type and go over to the 4th graph and press enter. If you hit zoom 9, it draws a box plot for you. And see, it even shows me the outliers right there. And if I hit trace, it'll start me at the far left, the minimum value 3, the lower quartile 6, median was 8, upper was 11 if you remember. And then it turns out 14 is the biggest number that's not an outlier because that's where the whisker stopped. And then if you go right, you can see the 25 and the 26 outliers. So they've already done this for you on number 3, and they put X's for the outliers, but that's fine. So which one had a higher rainfall? That you could tell that by the median. The median's the line inside the box. The median is one way to measure center of data, and it's the only center value that box plots show. It doesn't show the mode or the mean, but the line inside a box plot is the median, and clearly the city B has a higher median than the first one. So city B has a higher rainfall average. And also you can see the spread by how far does it go left to right, including the outlier. B is also seemingly more spread out than A, the total distance across. B has a higher average and a higher spread based on the median and the range, the overall range. So when you draw 2 box plots at the same time, you can tell that real quickly. Okay, so there was 3 problems here. These all came from the end of chapter 3. Section 3.3 is included in this test. Then there's 2 sections from chapter 4. Use the TI-84 Plus as needed, and it's really needed here. So I'm going to go to Stat and Edit and clear out this old list by going up arrow. So L1's highlighted, and then don't hit Delete, hit Clear, Enter. Type this new data in. X is going L1 and Y is going L2. So 11, 39, 23, 26, 14, -8, and 5. Right arrow over to L2, and now Y is going there. 16, -5, -7, 15, -9, 18, and 28. And don't try to sort these. Stat tests, up arrow to the LinReg t-test. This does everything of chapter 4. And you shouldn't have to change anything here, so go right down and hit calculate. Down arrow all the way to the bottom, there's R, the correlation coefficient, and there's a negative there, -0.593. So it's a negative correlation. First of all, that means as one variable increases, the other one decreases. And it's only 0.593. If you're below 0.5, it's weak. If you're above 0.8, it's strong, and anything between 0.5 and 0.8, like this one's moderate. So there's a moderate negative correlation here, probably nothing significant to say I can make good predictions with, though. Here's a scatter plot that has definitely a downward trend to it. As I travel left to right, a line that goes down the middle of the points is definitely sloping downward, negative correlation, but there's quite a spread diagonally. So this is probably a weak or moderate negative correlation. The correlation coefficient is definitely negative, and it's probably not appropriate because this is not very close to a straight line. It's definitely not strong negative correlation. It's not, the variables have a non-linear relationship. Or no, actually weak linear maybe is a better way to describe that. Non-linear is kind of like when it's curved. So weak linear, this is probably weak. It's definitely not, it's not that they have a linear relationship. That would be when the points lined up pretty well. And there's not really any outliers here. Outliers have to be like one point that's far this way or far down that way. So yeah, it's got to be this weak linear relationship. Nope, okay. Maybe they are considering this non-linear. Oh, no. Okay, well, it must be outliers then, but usually outliers, these are not outliers just because there's a little gap here. Let me show you this in the calculator. Remember, I have this one in, this is not the same problem, but I have this one in here. If I go and plot a scatter plot right here by choosing the first type and then hit zoom 9, see, these points are really all over the place. If you do that, if you put your equation in, you can put an equation in here and make a line go down the middle of it. And I still have the data here. The A value is, I guess I don't have it, stat tests, linreg t-test. If you grab the A and the B, 16.958, 16.958 plus a negative or minus 0.570, 0.570, and then you hit X, and then you hit zoom 9 to graph it. It'll draw a line on here that's called the line of best fit. The line tries to go down the middle of the points, and the more the points are closer to that line and lining up with it, then you have a stronger relationship. Outliers are not ones that are far to the left of the line or far to the right. Just because there's a little gap here doesn't mean that these 3 points are outliers. Outliers are when you're significantly above or below the line, but usually like when there's 1 or 2 that are way above or below. So I can tell from this problem right here, the line would do something like this down the middle of the points. And there are some points significantly above it and significantly below, but usually when there's a whole bunch, they're usually not all out. There's usually not this many outliers. So the answer is definitely not this. So I guess they're saying there's outliers because I've already gotten this wrong twice. Okay, so I don't really agree with that, but what if I try another one? Is it this extreme every time? So again, same kind of deal. This is definitely not appropriate because there's no line that you can draw that most of the points are close to. And I guess they're counting this as outliers. But that's hard to tell without the line being on there. But at least you know when you do your review number 5, this is problem number 5, if you can't quite see the numbers above, but there's number 5. Just say there's outliers here, but that's kind of weird in my opinion. Let me show you a good example of what an outlier is. See, if you, in a scatter plot, what an outlier is. If you have points that are pretty well lined up like this, and then there's one way over there, that's not an outlier if the line down the middle of the points goes close to that one like it would right there. That's just having a big gap here does not make this an outlier. Outliers are when you're far this way or far that way. So if you had points pretty well lined up and draw a line down it And then there was one right there and or way over here. Those are outliers because those are far from the line that predicts everything. That's what it takes to be an outlier. It's not when there's a gap this way. It's when there's a gap in the opposite direction that the line's going. And it's hard to tell that on this scatter plot, in my opinion. On this number 5 problem, it's hard to tell where the line would go. So it would help maybe if they gave us the data here and we could run this in our calculator. But okay, a survey of U.S. adults showed that there is a negative correlation between age and education level. Does this mean that people become less educated as they become older? See, that this is a fallacy in correlation. When correlation is strong and when it's above that 0.8 level and we call it strong positive or strong negative correlation, all that tells us is that we can use one variable to predict another one very well. But it doesn't necessarily mean that one variable causes the other one to happen. There may be a cause and effect, but it's not automatically cause and effect. So just because there's a strong negative correlation between age and education level, it doesn't mean that getting older makes you dumber or something like that. So increasing age as people become older does not cause. You can never say cause and effect from correlation alone. It does not cause this other variable because correlation never implies that there's automatically causation. It's one of the big no-nos to try to make a conclusion in chapter 4 about that. One time there was a Texas politician who said there was a strong negative correlation between teacher salaries and the STAR test scores, which means that schools that pay teachers more have low test scores and schools that pay teachers lower have high test scores. But just because you can predict that well doesn't mean that the salaries are causing that to happen. The politician he said, let's cut every teacher's salary in half and all the scores will double. But see, that's the problem, is that the salaries are not causing the scores. It's that students that are in like rural areas that have small class sizes, they get a better education because their teacher can spend more time with them, but they don't have to pay those teachers as much because they have very small classes. When you go to the inner cities, and then there's other issues like economic disadvantaged students are mostly more likely to be in inner city schools. And then those teachers have large class sizes and they got to be paid for all the duties they have to do. That's what they're getting paid for. It's not the students' fault that the class sizes are large and that they're in areas like that. But the teacher's salary has nothing to do with what their test scores are becoming. Okay, so let's put this into L1 and L2 again. Stat, edit, and then just clear out list 1 and list 2. Go up to the top and hit clear enter. Go over to L1, up at the top, clear enter. L1 gets 5, 4, 2, 6, and 3. Y goes in L2, so 4, 5, 1, 3, and 6. Run your linreg t-test. Stat, test, up arrow to the linreg t-test. Go down and hit calculate. Even though this problem doesn't care about R, I would take a look at it real quick. See, R is 0.164. That's an extremely weak positive correlation. The scatter plot's going to have kind of like a random assortment of dots. The A value is exactly 3, and the B value is exactly 0.2. And notice at the top it says y equals a plus bx. So that's how you write this equation. Y hat equals 3 plus 0.2x. You just plug in the A and plug in the B from your calculator. That's the regression line. And then in your calculator, you can actually put that into y equals. See how I put that other one in there? So if I clear this one out and type 3 plus 0.2x, zoom 9, it'll draw this scatter plot and try to draw a line in there. But see, the points aren't even, there isn't that many points, first of all. There's 4 that are really well lined up, and then there's this 1 point that's way offline from the rest of them. That's an outlier right there. If you took this point away, the slope would go right through all these other points perfectly. There would be a strong negative correlation if you just took this 1 point away. That's an outlier. But because it's there, it's pulling the line from this slope to this. It's making it positive, in fact, slightly positive. But the line only goes close to 1 point. All the other points are really far from the line because 1 point is messing all this up. This is what that other problem, number 5, should have let me do. So if I could tell for myself where the line was going, but there was no way to do that for that problem. 1 point can have a great effect on the correlation and where the line is going, and that's really what an outlier is all about. 8, they have done the Lin-Reg t-test for you and spit all this data out. Now write the equation of the line. Well, you just grab the a and the b. See how it says y equals a plus bx here? Plug in a, do not round, it says here. So I usually round to 2 or 3 places, but they want the whole thing here. 2.16390317. And b's positive, so plus 0.3220572, and then type in x. There's the regression line, or what they call the line of best fit. What is the correlation? That's R, 0.616. Maybe we don't want to round here either. Okay, I'm not sure what they want this rounded to, so 615688207. And that's a moderate positive because it's between 0.5 and 0.8. Sometimes moderates are good enough to make decent predictions with, but usually it takes strong correlation to do so. Predict the price when the prime interest rate is 6.5%. So we're going to plug 6.5% in for the x. See how x is the percent. So if I use any calculator now, 2.16390317 plus 0.3220572 times the x that they're giving me of 6.5. So if the percent's 6.5, I predict that the y variable will be 4 decimals. The price is y. 4.2573. Bump this 2 up to a 3. 4.2573. Same deal here. The intercept is the A. That's definitely A. Y-intercept is A in statistics. So the slope is B, but it just says body weight there, but I'm going to assume that's the slope. 0.7672468, and then put X. This is similar to the previous problem, just they're getting this from Excel rather than from a calculator. Predict the brain weight for a bird whose body weight is 270, so plug 270 in for X. Body weight is the X. So 3.788025 plus 0.07672468 times 270. Round to 3 decimals. 24.504. 25.504. Okay, that was weird. I misremembered it. 24.504. Okay, that was number 9. 10. Okay, how probable is it? Now we're in chapter 5, so this is where probability started. So when you have, if probability is 1 exactly, then it's guaranteed to occur. If they say there's a 1 probability of rain or a 100% chance of rain, it's guaranteed to rain. It is certain to happen. If the probability is 0, then there's no chance it'll happen. It's impossible to happen. The event cannot happen. That's the extreme of probability. It's always between 0 and 1. Probability can't be negative. Someone made a mistake if it's negative. And it can't be bigger than 1. That's a mistake too. It's always between 0 and 1 otherwise. And when it's close to 0, then it's very, very unlikely to happen, especially this one. 0.03 is really low. It's not impossible, but it would be very unusual for it to happen. If it's pretty close to 1, like 0.92, if there's a 92% chance of rain, it's not guaranteed to happen, but it's pretty likely to happen. The event is very likely to happen, but not quite certain. 0.5, it's a 50-50 shot. It's just as likely to happen as not. The event, where is it? Is as likely to happen as not. 0.18 isn't quite as bad as 0.03, but it's unlikely to happen. It may happen, but not very likely. Okay, that's all of them. Okay, during a recent season, Clayton Kershaw threw some of these pitches. What is the probability that he throws a fastball? That's straight basic or single probability right there. Good over total. He threw 3,121 fastballs out of so many total pitches. 1321 divided by the 2591. That's just good over total. That's literally how probability got started way back in the day. It was just simple basic probability. So almost 51% of the time he threw a fastball round to 4 decimals. 5098. Because pitchers only throw one pitch at a time, a curveball or a slider, you can't get both of those at the same time. You can only throw one at a time. So this is the ORs that they teach in junior high, where you just add the two cases together. Curveball is 415. Sliders are 829. You just add those together. 415 for curveballs plus 829 for sliders. And then you divide by the total again. You always divide by the total. 4801. But that's an OR that you can't be both at the same time. That one's mutually exclusive. Okay, in a casino in Nevada, there's this game called Roulette where they number 1 through 36, and then they basically have 37 and 38 by having 0 and double 0. 18 of the first 36 numbers are red, and there's 18 that are black, and the 0 and the double 0 are green. What's the probability the ball lands in a green pocket? Well, 2 of them are green out of 38. That's, again, basic or single probability, 2 out of 38. And do they want a fraction or a decimal here? 4 decimals. 0.526. See, this is the house's way of making money in the long run. 5% of the time they basically win and the players lose automatically. You can actually bet on that happening, but in the long run, every 38 times the game is played, players basically only get paid for winning 36 of the 38 times, and the house wins 2 out of every 38 times. If you bet on green every spin, you will lose more than 90% of the time because you only win 5% of the time. Explain why this is so. You will lose more than 90% of the time because of the law of large numbers. So if you only do it 10 times or 50 times, you can beat the odds. But if you play thousands of times, you're only going to win 5% of the time. You're going to lose 95% of the time. In the long run, you will lose 1 minus this. That's the complement. The second type of probability is complement. If you do 1 minus your chance of winning, you'll get your chance of losing. You're going to lose 9.474 of the time. Well, they want a percent actually, so I got to move it over twice. 94.74. Okay, that was 12. Okay, look on the formula sheet. There's a box for probability right here. The probability of A or B is A plus B if they are mutually exclusive. But if they're not mutually exclusive, then you have to do A plus B minus A and B. So a problem like 12 or 13, whatever, when we're on number 13, you can literally check this. Does 0.3 plus 0.2 equal 0.4? If so, they're mutually exclusive, because then there's nothing to subtract. But 0.3 plus 0.2 is 0.5, and that doesn't equal 0.4. So I would have to subtract 0.1 to make it go down to 0.4. So that means the probability of A and B is 0.1, and since it's not 0, then these are not mutually exclusive. These are not mutually exclusive because A plus B didn't equal A or B directly. When they are mutually exclusive, then the ORs are just simply A plus B like they taught you in junior high. But here it doesn't work. The simple formula doesn't work here, so that's why they're not mutually exclusive. Or they can give you kind of like scenarios. If Stacy's pursuing a major in biochemistry and Stacy's pursuing a minor in animal sciences, can she do both of these at the same time? Yes, people do majors and minors in four-year colleges all the time. You can major in one category and minor in another one. So can Stacy do both of these at the same time? Yes, so then no, they're not mutually exclusive. Because mutually exclusive has that negative in its definition that you cannot be both at the same time. So if I try another, maybe there's one where I can't be both. Can one student be a valedictorian and a salutatorian at the same time? No. So then yes, these are mutually exclusive because you can only be one or the other of those. So I did this problem twice. Once it was mutually exclusive and the first time it wasn't. Okay, I like these chart problems where there's a chart given to you, and at least this is with real simple numbers too. These chart problems are good because you can have all 5 types of probability in the same problem, and you often don't even need formulas. So runny nose or sore throat, runny nose, sore throat, or not for each one. And there was a 6 and a 2, I think, like that. 8 and a 5. Okay, 6 plus 2 is 8. 8 plus 5 is 13. 8 plus 13 is 21. There's the grand total right there. Every probability will be over 21 unless they give me that conditional probability. 6 plus 8 is 14. 2 plus 5 is 7. And notice 14 plus 7 is also 21. Find the probability a random selected student has a runny nose. So that's a singular basic probability. All I care about is one thing. Do they have a runny nose or not? Well, 6 of the people have a runny nose and a sore throat, and 8 have a runny nose without a sore throat, but there's 14 that have a runny nose of one kind or another. So the probability of a runny nose, good over total, is 14 over 21. Which could reduce to 2/3, or it could be a decimal like 667, depending how they want it. It says round to 4 decimals up here, so I'm going to put 0.6667 for that one. Find the probability somebody has a sore throat. There's another singular basic probability. That's this one right here, 8 out of 21. 8 out of 21 to 4 decimals is 3809, but there's a 5 after that, so make it 3810. Add 1 to this 09 and turn it into a 10, 3810. Whoops, I got to do all of them before I check them. Okay, now here comes the or. Runny nose or a sore throat. Well, you can have both of those at the same time. In fact, there's 6 people that have both of them, because there's runny nose, there's sore throat. So if you were to do runny nose, 14 out of 21, or a sore throat, or as you always add, 8 out of 21, the issue, if that's all you do, is you're going to get 22 out of 21, which is an impossible answer. Probability can't be bigger than 1. The top can't be bigger than the bottom. And that's because you're double counting these 6 people that have both of these. These are not mutually exclusive, so you need to subtract the ones that are both, and that'll drop it from 22 down to 16. 16 out of 21. 7619. Find the probability has neither a runny nose nor a sore throat. Okay, to me that sounds like both of them are saying not. So I want not a runny nose nor a sore throat. And the word nor should be the same thing as or, just neither, either or, nor, neither nor. I'm remembering I think I messed this one up before too. I think what it is they're saying do like the opposite of this case. That runny nose or sore throat has a 76% chance. So what's the chance you don't have that? Like a complement? I think it's the complement of this answer. So if I 1 minus 7619, that's 2381. I don't think it's those 2 circles that I just circled. That's what I thought it was originally, but 2381. I think they just, part 4, you just do 1 minus part 3. Yes, okay. I remember I messed that up before when we were in chapter 5, but sometimes it's just the wording of it. You got to get it wrong one time to see what they're actually asking. Okay, so in mutually exclusive is when you can't be both at the same time. Independent is when the 2 events do not affect each other. So if I go to a class somewhere and grab a student, could that student be a man and could that student belong to a sorority? And the fact that I know they're a man, could that give me information about being in a sorority? See, these are definitely not independent because sororities are for women. Men go to fraternities. So if you tell me there's a man here, then I know there's no chance of them being a sorority. So given information about the first thing, if that gives you any idea about something about the second thing, if that helps you answer the second thing better, then they're not independent. Independent is when one doesn't affect the other. But gender affects which type of fraternity or sorority you go to. So these are definitely not independent. And then could you be both at the same time? No, you're not. Men are not allowed in there. So a man or a sorority, those are separate categories. You can't be both at the same time. So these are mutually exclusive, but they're definitely not independent. Okay, so compute A and B. Okay, so this is coming from this second formula right here. There is an A and B formula, but that only works if they're independent. And if they're dependent, then you have to know the conditional probability. We don't have that given to us here. But if you look at the second OR formula, A or B, it's A plus B minus A and B. It's got that and in it. So what if I use that formula right now? The probability of A or B is probability of A plus probability of B minus probability of A and B. The question wants A and B, but it gives me these other 3 things, which is why I knew to use this formula. The probability of A is 0.4. The probability of B is 0.6. We're looking for A and B, so I'll just call that X. And we're told that the OR is 0.7. So you can solve for X algebraically. 0.4 plus 0.6 is 1.0 exactly. Subtract 1. That's negative 0.3, and divide by negative 1, x equals positive 0.3. So this is a case where they're not mutually exclusive because a plus b doesn't equal a or b, but a plus b minus something that's not 0 gives me a or b. That's when they're not mutually exclusive, and it allows me to find a and b also. Are they mutually exclusive? No, because if they were, the a plus b would equal the or already. 0.4 plus 0.6 doesn't equal 0.7. The A and B, when A and B equals 0, if A and B equals 0, then that's when they would work, because if this x was 0, then it wouldn't even be here, and then the 0.4 plus the 0.6 would equal 0.7, but since it doesn't, then x has to be something other than 0. So anytime a and b is 0, then you get the shorter formula. And that even makes sense if you look at the formula sheet. See how the first formula just says a plus b. The second one's almost the same thing, a plus b, but then there's minus a and b. If a and b is 0, then you have minus 0, and it disappears. Anytime you have minus 0, you can just ignore it. And then the two formulas are the same. So that's why if a and b is 0, then the two events are mutually exclusive. These events are not mutually exclusive because a and b did not equal 0, actually. Whoops, I clicked the wrong one. A and b here was not 0, it was 0.3. So because it's not 0, then they're not mutually exclusive. Are they independent? Well, they're only independent if, right here, if a times b equals the a and b answer. And we know the a and b answer now is 0.3. And we know a and b, does 0.4 times 0.6 equal 0.3? Does 0.4 times 0.6 equal 0.3? No, it's 0.24. So that formula didn't work either. So they're not independent either. They're not independent because a times b did not equal a and b. Okay, here's another one of these chart problems, except I don't like how they put such large numbers here. It takes a while just to write it down and add it up, and you might have a slight adding mistake and miss the whole problem because of a slight calculation error. So you can have expertise or not. You can be a music teacher or administrative staff. So expertise or not. Music teacher or administrative staff. 8143. Whoops. 1822. 24,302. 5432. Okay, so I got to add up 8143 plus 1822 is 9965. 24,302 plus 5432 is 29,734. Now add that to 9965. The grand total is 39,699. Every answer will be divided by this unless you do conditional. So now add these two together. 24,302 plus 8143 is 32,445. Five, 432 plus this 1822 is 7254. make sure that these two add up. These two need to add up to the same total. So add 32,445 to what I have. Does it equal 39,699? Yes. So then I know I did all the adding correctly. What's a probability person is a music teacher. There's a singular basic probability. Music teacher is right here. So it's this 99 number divided by the grand total. 9965 divided by 39699. Whoops, I hit minus, not divided by. And what do they want it rounded to? Round to 4 decimals. Okay, let's try that again. 9965 divided by 39699. 2510. I've got to check them, put them all in before we check them. Expertise, that's a singular basic probability too, which is right this way. So now we're going right here, expertise. 32,445 divided by the grand total. $8172, except there's a 3 after a 7 after that, so bump it up to a 3. 8173. Expertise and music teacher. And don't use the formula sheet. That it won't work to do A times B here. We don't know if these are independent or not. They're probably not, but we don't know. So the nice thing about these chart problems is you don't need a formula to do ands or ors or conditionals. They're all in here. We want to do expertise and music teacher. Expertise is this purple one that I'm now drawing in green. Music teacher is the one that was in red. And then see where they meet each other in the table? The part where I have 2 greens circling it. This is the ands right here. Ands are where they meet in the table. These are the people that are both. So I don't need a formula here. It's just 8143 divided by the grand total. $2051. $2051. Now here's, see again, they do have, I think they have it, maybe they don't even have it. No, they don't even have the conditional formula on here. There is a formula for it, but again, you don't need it for this problem because I can just look at the chart and tell the answer. Music teacher given expertise. And remember, you want to do the given part first. So circle expertise, the second thing here, and then the end of that row or column is your new total. It won't be the grand total. And then find music teacher inside of that. Music teacher given expertise. Given that this person has expertise right here, the end of that row is your new total instead of the grand total. This is the one time we don't use grand total. So this will be your denominator. And then either this or this will be the numerator. Whatever the problem's asking for, it asks for music teacher. So you want to grab music teacher in the row or column you're in. 8143, but you divide by the second category, which was expertise, 32,445. 2509, except there's a 7 after that, so make it 2510. And okay, let the event, A, be the event the person's a music teacher, B is that they have expertise. Are they independent? Well, we could either, if we know the and answer, we did know the and answer, and we know both of the basic ones. So remember, the formula says that A and B equals A times B if they're independent. A and B equals A times B if they're independent. So what if I try that, since I know all 3 of those? This is the probability of A, this is the probability of B, and this is and. So does this 2510 from part 1 times the 8173 from part 2, does that equal 2051 in part 3? If it does, then they're independent. And it does, see, 2051. So that's why it's yes. But many of these chart problems are not independent. But you can at least check that out at least. Okay, the end of chapter 5 had these how many ways can you do something. So when ordering a server type of computer, there are 3 choices of hard drive, 5 choices of memory, 3 choices of video card, and 3 choices of monitor. How many ways can a computer be ordered? I have to choose 1 out of 3 hard drives, and 1 out of 5 memories, and 1 out of 3 video cards, and 1 out of 3 monitors. That's the junior high problem, where I'm choosing 1 out of 3 hard drives times 1 out of 5 memory cards times 1 out of 3 video cards times 1 out of 3 monitors. There would be 135 different computers available. Or you don't choose one of these, one of these, one of these. Sometimes you choose so many out of a total. We have 10 people in a committee, and they have to pick a president, a vice president, a secretary. We have to choose 3 out of 10 people. 3 out of 10. 3 out of 10 is not 3 times 10. It's either 10, always put the bigger number first, math, probability, permutation 3, or it's 10, math, probability, combination 3. It's one of these 2 answers for sure. And when order matters or you treat the people differently, then it's a permutation. And we talked about this during the homework. Presidents are treated a lot different than secretaries. So this is when order matters or the objects are treated differently. So that's why it's the 720 answer. But this is how many ways in part 1. Part 2 and 3 asks for probability. What is the probability that Ruben is president and Yolanda is vice president? So we still have to pick all 3 is what I messed up on the homework for this problem. So we still have to pick 3 people. We got to pick a president, and there's only one way to do that. That first guy has to be president. There's one way to get the vice president female that they want. But then we got to pick still got to pick a secretary. And there are 10 people in the club, so any of the other 8 people in the club could be the secretary. So there should be 8 ways to do this out of the 720 we just got for part 1. Because that's the total number of ways to pick 3 out of 10 people. So Ruben has to be the president. Yolanda has to be the vice president. There's only one way to do each of those. Just make them the president or the vice president. But any of the other 8 people could be the secretary then. And you have to do all 3 positions. That's how I did this wrong last time. Does it say decimal or fractions? Yeah, it says reduced fraction. So both of these divide by 8, I'm pretty sure. 72 divided by 8 is 9. So this is 1 over 90. Or if you have a graphing calculator, 8 divided by 720, math, enter, turns it to 1 over 90. Okay, either Yolanda or Ruben is president, so there's 2 ways to do that, one or the other person. There's 2 ways to pick the president, because it can be either one of those 2 people. But we still got to pick these other positions. And what is the probability? So it's got to be over 720. And the other is vice president, so there's only one way to do that, because whoever doesn't get president gets the vice president automatically. And then it doesn't say anything about the secretary, so then you got those 8 ways to pick secretary. because these first two people are going to be one position or the other. So now it's 16 over 720 rather than 8 over 16 over 720. Math, enter, enter. 1 over 45. Whoops. Okay, so I know you can't see the top quite all the way. I didn't want this to be too slanted, but there, we got all 20 of these correct so far. There's 30 problems in the review, so we're 2/3 of the way done. So let me do the magic word of this final video of this Unit 2. This is the 5th video of Unit 2. And you may know the first 4 magic words all had a similar theme, and there's really only one answer left. So this is going to be the Dynamo, Houston Dynamo. Okay, in a certain state, license plates consist of 3 digits followed by 2 letters. How many different license plates? 3 digits and 2 letters. So I want to do a digit, and it's just automatically multiplied together. Digit, digit, letter, and letter. And this is how many license plate, not probability. Every time you get a digit, you put a 10. Anytime you get a letter, you put 26. If there's no restrictions. So 10 times 10 times 10 times 26 times 26. There's 676,000 license plates possible. How many license plates have the letters J, O in that order? So the first 3 are still numbers apparently. And then you got to have letter J first and letter O last. Well, there's only one way to put letter J in that 4th slot. And there's only one way to put O in the last spot. So this has to be the 1 letter J. This has to be the 1 letter O. Both of these are 1s then. So 10 times 10 times 10 times 1 times 1 is the same thing as just 10 times 10 times 10, which is 1,000. Whoops. Didn't get the 1. 1,000. If your name is Joe, what is the probability your name is on the license plate? Okay, so I remember I did something wrong with this one last time too. Your name is Joe. 1,000. There's 1,000 license plate with Joe, and there's this many total. What is the probability? We are doing probability here. Good over total. 1,000 over the 676000. 00148. Yes, okay. I did something wrong with that during the homework. I don't remember what I did the other time. But I just took part 2 and divided by part 1 because this is how many ways you can get Joe, and this is how many total ways you can do it. So literally good over total. Okay, now we're up to chapter 6, the final chapter of this unit, and then unit 3 will start with chapter 7. So first, is this a valid probability distribution or not? The x's have to be discrete, and I can't tell what they are because they don't say what they are, but at least these could be discrete numbers. They could be exact values only. So we don't have to check that rule, but then each individual probability has to be between 0 and 1. None of these individually can be negative or bigger than 1, and none of them are. They're all 0 point something. So the only thing left is the third rule is if you add all the probability together, it's supposed to equal 1 exactly. Well, this isn't going to do it because the bottom 3 already add up to 1. See, this adds up to 1.3, so no, this is not a true probability discrete probability distribution because the sum of all probability here is greater than 1. All the probabilities are between 0 and 1, but the probabilities do not add up to 1. They add up to 1.3. Okay, then we want to get the probability of 1. We have 4 tires on a car, and any of the 4 tires or all of them could have low air pressure. What's the probability exactly one tire has low air pressure? Right there, 1 is 0.1. The probability of 1 is 0.1. Greater than 3, well, the only one greater than 3 is 4, so that's 0.2. But say it said like greater than 1, then you'd have to add the 2, the 3, and the 4 together and add all those up. But greater than 3 could be the same thing as just saying 4, so 0.2. Since cars don't have more than 4 tires. Find the probability that all 4 tires have low air pressure. That's what we just answered, 0.2. Find the probability that no tires have low air pressure. 0 tires having it is 0.2 also. So this is an easy question when the chart's already made for you, because then you just have to look up each answer. Okay, the mean, and this is probably the best thing, is if you have a TI-83 or 84, you can put the X's in L1, stat, edit, clear out list 1 and list 2. L1 gets the X's, 0, 1, 2, 3, and 4. Go over to L2, and this gets each probability. So if you do the stat calc 1var stats like we did for the outliers, for the 5-number summary, if you just run it with L1 only, like in the people that have pasting screens, it won't let you put L1 and L2 at the same time. So you run it and you get these wrong answers. But then you can instantly hit second enter and it calls up the last statement you typed in, and then hit comma L2. The mean is the very first number, 2.1. And the standard deviation is the last number visible, which is 1.1357, 3 decimals. So 1.136, bump this 5 up to a 6, 1.136. Then this can be an extremely easy problem. Or you can do it out the long way like I showed during the homework, and that's okay if you don't have a graphing calculator. Okay, as soon as you hit binomial, then you can go to the formula sheet, and things are easier again. The mean of a binomial is right there. Mean of a binomial is simply n times p, the two things they always give you in the paragraph. So n is 4 and p is 0.8. I guess we're not up to the mean yet. So determine the probability equals 2. And that you can either use this binomial formula on the formula sheet, or you can do, if you're doing exactly 2, that's second vars, up arrow to binom PDF. And this is a typing calculator, so I have to put the n first, then the p, and then the x. 4, 0.8, and 2 exactly in that order. 4, 0.8, and 2. 1536 exactly. Here's the mean. That's what I thought it was asking for. The mean is simply n times p. 4 times 0.8, I could do that here. 4 times 0.8 is 3.2. The variance and standard deviation are on the formula sheet too. The mean of a binomial is n times p, 4 times 0.8. The variance is n times p times q, and they never tell you q. And then, of course, standard deviation is always the square root of the variance. And if p is 0.8, you should be able to get q. Q is always 1 minus p. So 1 minus 0.8 is 0.2. So the variance is n times p times q, 4 times 0.8 times 0.2. .64. And the standard deviation is always square root of variance, so square root of 0.64 is 0.8. There's the three easiest things in binomials, is doing probability of a single value and the mean and the variance and standard deviation. I get counting that as a third thing. Here's another probability of only one thing, just 5. A student takes a 10-question multiple choice test, so there's n. Each question has 4 choices, so you have to guess one of the 4 choices. So the probability is 1 out of 4. Usually they tell you what it is that you need, but here they're making you find it yourself by knowing basic probability. Good over total is 1 out of 4, or 0.25. So this is a binom PDF because I only want to do 5 for the x. The n is 10. I just figured out the p is 0.25 and the x is 5. That's second vars, up arrow to binom PDF because I'm only doing 5. 10 is n. 0.25, whoops, 0.25 is p, and I'm trying to get exactly 5 questions right. See how getting 5 out of 10 questions on a test, that's a bad grade. That's a 50%. That's a failing grade. And this is somebody who's just guessing randomly on every problem. They only have a almost 6% chance they get a bad grade, actually. So imagine trying to get a good grade. It would be even a lower probability. 0584. 0584. But if you want to get more than 3 questions right so that you can get a passing grade, see, you're going to get somewhere between 0 and 10 of these questions right if you're just guessing. More than 3 means 4 and higher. So if there's an inequality, it's definitely a CDF and not a PDF. If it's less than or equal to, then it's going down to 0 already and you don't put a 1 minus. But if it's greater than or equal to, then you need to turn this around and go down to 0. That's when you put 1 minus. Binom CDF. The 10 and the 0.25 aren't going to change. And I'm doing 3 down to 0, so this is a 3 no matter whether the question has a 3 or not. It's not always what's in the question, it's what number you starting at as you go down to 0. So 1 minus binom CDF, 10, 0.25, and 3. And you can type the 1 minus first. 1 minus second vars, up arrow to the CDF option, not the PDF. 10, 0.25, and whoops, I didn't get the 0.25 there. And then 3. So if you do a CDF with 3, it does 3, 2, 1, and 0. And then the 1 minus gives you the opposite, 4 through 10, exactly what I'm looking for. So 2, 2, 4, 1. Denver International Airport, 83% of flights are on time. There's P right there, 83%. A sample of 14 flights, there's N. Find the probability that all 14 of them are on time. N is 14, P is 0.83, and we want all 14, exactly 14. That's a PDF. This is second vars, binom PDF. 14 for N. 0.83, got to change that percent to a decimal, and then do 14 again for X. 0736. Exactly 12. There's another PDF. Whenever you're just doing one case, 14 or 12 only, that's PDF. The first two numbers aren't going to change either. So second vars, binom PDF again. 14.83, and this time 12 because I want exactly 12. 2811. 12 or more. See, now it's an inequality. 12 or more. Same kind of deal as this problem. 12 or more. There's 14 of these. 12 or more is like this, so I need to turn this around and do 11 down to 0. 1 minus binom CDF. 14.83 aren't changing. But I'm doing 11 down to 0. Even though the question said 12 or more, I'm putting an 11 there. So 1 minus binomial CDF, 14.83, and 11. 1 minus second vars, up arrow to binom CDF, 14, comma, 0.83, comma, 11, not 12. 5, 6, 5, 9. Bump this 8 up to a 9. 5, 6, 5, 9. Using a cutoff of 0.05, would it be unusual for 13 or more flights to be on time? So let's calculate the probability of 13 or more, which is, this one was 12 or more. So 13 or more is 13 and 14. We got to do 12 down to 0. 1 minus binom CDF, 14.83, and 12, because I'm doing the opposite of 13 and up, which is 12 and down. 14.83 and 12. It's the exact same thing as the last one, except 12 instead of 11, so I'm going to hit second enter and just type over the 11 with a 12. 2848, 2848. So would it be unusual? No, because you have to be less than 0.05 to be unusual, and 2848 is not below 0.05. So if there's a 28% chance of rain, there's a low chance of rain, but it's not like it's impossible to happen. And not that less than 0.05 is impossible either, but it just starts to become very unlikely. Whoops, okay, I didn't answer that last box. It would not be unusual because the probability is 2848, which is relatively high for being considered unusual. Okay, here comes Poisson. So this is the problem where if they give you t equals 3, that means they want you to multiply the lambda by 3. So do 1.6 times 3 first. You're changing lambda to 3 times is great. The lambda is 4.8. And the only other number in a Poisson is the 2 or whatever. Maybe they want to do more than 2 or less than 2. But this one's just 2 only, so that's a PDF. This is a Poisson PDF with 4.8 first and then the 2 that's in the question. So just like binomial, you can do Poisson PDF or CDF. Sometimes lambda changes to a different time interval. So 4.8, comma 2. 0948. In a certain city, the number of potholes on a street has a Poisson with a rate of 4 per mile. 4 per mile. See, that's lambda at first. The original lambda, number 29, lambda is 4 per mile. So if a question says find the probability of something per mile, then you don't need to change the 4, but maybe it's per 2 miles or 3 miles. If they change the unit from 1 mile to something bigger or smaller than a mile, then you got to multiply lambda or divide lambda by whatever you're changing it to. And it says, let X represent the number of potholes in a 2-mile stretch. So it's a little off screen, but it says 2-mile stretch. So we just doubled the miles from 1 to 2. 2 miles, so then you just got to double the 4 to 8. And then if you're doing either PDF or CDF, whether it's PDF or CDF, you're definitely going to put an 8 in this first slot. And this one is PDF because they only want exactly 5. PDF with a 5 at the end. But the 4 changed to an 8 because they doubled the mileage. Poisson PDF 8, 5. Zero 916. Part 2 wants more than 1. That's a CDF. More than 1. So this one was exactly 5. Now we want to do more than 1. This can go on for hundreds or even maybe infinite. But more than 1 means 2 or higher. We can't do that, so we're going to do 1 and down. 1 minus, since we're switching back to going down to 0. Definitely a CDF because it's an inequality, not an exactly 1 number. And I think it's still 2 miles, so we'll keep this as an 8, but then we're going to put 1 down to 0. 1 minus Poisson CDF 8 and 1. Oops, CDF 8 and 1. 9969, but there's an 8 after that, so 9970. Whoops, this one. There's 2 ways to do between 6 and 8. One is to do a CDF with 8 and a CDF with 5 and subtract them. You could do Poisson CDF without the 1 minus because I'm doing less. I'm doing 8 and down, really. I could do a CDF with 8. I can do a CDF with 5. So you do 5, not 6. Because if you take 8 down to 0 and 5 down to 0 and subtract them, all that's left is the 8, 7, and the 6. So if you subtract these two answers, 5925 minus 1912, this is one way to do it and get 4013. Or you can do a PDF for 6, 7, and 8 literally. So what if I do second vars, PDF, first I'll do a 6, then I can do a 7, then I can do an 8, and remember the answer is 4013, so if you add all 3 of these together, it should equal 4013. See, 4013. So I did that 2 different ways and the answers agreed. Okay, then the mean is easy in a Poisson. The mean is whatever lambda is, as long as you're in the correct units. So there's a rate of 5 per mile here. So as long as they ask about per mile, then the mean's 5. But if they ask for 2 miles, then the mean would be 10. Here they want a 3 mile stretch, so you just multiply the 5 by 3, and the mean's 15. The mean of a Poisson is literally whatever lambda is, as long as you're in the correct units. They usually quote you like per 1 of whatever it is, like per 1 mile, and then maybe they change it to 3 miles or 2 miles, or maybe they keep it 1 mile. So once you get the mean, then the standard deviation turns out just to be the square root of the mean, strangely, because normally we do the square root of the variance, but the Poisson is the one time you do square root of the mean to get the standard deviation. Round to 4 decimals, so 3.8729, but there's an 8 after that. So bump the 29 up to 30, 3.8730. Okay, So this video is just under an hour and a half, and I can tilt it now and show you that everything is green and all 30 problems are correct this time. And the only thing I got wrong this time, I learned from my mistakes apparently, because the only thing I got wrong, and I sort of disagree with it, is on this number 5 about the outliers. I don't really think there's outliers here, but if they say there's outliers, then go with that answer, I guess. Okay, so there's the formula sheet. Make sure you print page 1. In the next unit, you'll see we're going to use a few other pages, but for now, you really just need this chapter 4 box, this chapter 5 box, and the beginning of chapter 6 helps. We never did this kind of stuff, but so that alone, if you print that out and don't write anything on it, then you're allowed to have that on the next test. And then we'll add a few more to it in the next unit as well. But this was the review number 2 for 1342, 0242, 1342. And we did all 30 problems in this video.